Good afternoon. So today's lesson will be on cleaning, and the cleaning in the laboratory goes hand in hand from the last topic which covered on the laboratory hazard, where we learned that without proper cleaning, serious hazards can be encountered in the laboratory, and the most important one is the biological hazards. Biological hazards can be easily prevented through thorough cleaning. Now, there are different types of cleanliness. There is biological cleanliness, there is physical cleanliness, and then there is chemical cleanliness. Now, so the topic is cleaning of labware, and the labware are examples of those wares used in the laboratory, like the glassware. We also have plasticware and the other instruments used in the lab. So for glassware, we have examples of conical flask, volumetric flasks, burettes, and so forth. We have metallic wares also, like the spatula, the metallic ones. We also have plastic ones, and also those containers used for storage of chemicals, used for storage and transportation of chemicals. Now, so when we discuss on general cleanliness, the general cleaning procedure for glassware and plasticware. So we start with plasticware and glassware. So we start by saying that laboratory ware should be kept clean and ready for use at all times. So avoid rushing and cleaning glassware immediately for use. Always have them ready. Now, in general, superficial dirt on burettes and pipettes and similar items can be cleaned by washing in detergent. That's the first step. Second step, rinsing thoroughly with several applications of water. Then rinsing thoroughly in distilled water. Then finally drying, preferably in an hot air oven. Now, however, some of these containers can be dirty or contaminated in several ways, which will make them difficult to clean. Therefore, we need a stronger cleaning solution. So, first of all, you must protect our hands by use of rubber gloves. So to clean the burettes and pipettes or a similar piece of glassware, you can use the following solution, which can be prepared by adding sodium or potassium dichromate, 30 grams, then add chlorine sulfuric acid and distilled water. Now the procedure is, you dissolve 30 grams of powdered sodium or potassium dichromate in 100 ml of water, then add 900 ml of chlorine sulfuric acid, the solution of dichromate, and add few ml of acid. Now, if you remember, when adding acid to water, as you should always remember that you always add acid to water, not the other way around. And as you do so, it's an exothermic reaction which really generates a lot of heat. So you should add little by little while stirring. And you don't pour directly, but you tilt the container then so that you can pour the acid from the sides. Don't just throw it directly, because it can cause emissions of aerosols or splashes, which can splash into our skin or our eyes can be very harmful. Also, you use a wide-mouthed container. Don't use a small mouth container like a concave flask or a volumetric flask. Now, once you have added, allow the solution to cool. Then decant the solution through a funnel containing glass wool into a Pyrex bottle with a glass topper. Now, Pyrex glassware are tough ones. They are a bit tough. Now, so for cleaning soda glass are normally a weaker glass. They are weaker. So nitric acid is used in place of sulfuric acid. So use nitric acid in place of sulfuric acid. Okay. So if you remember, we say soda glass are a bit, they are not as tough as borosilicate, as Pyrex. So you try to use an acid which is not very strong, because it will be harmful. It will eat out the glass. So now when we go to cleaning a burette, the cleaning solution is placed in the burette for some time, that is like soaking. Then return the plastic. Then you return the solution, the cleaning solution, with a plastic bottle. Now rinse the burette thoroughly with tap water. While checking whether the water clings to the sides of the wall. So you rinse, then you check whether the water will cling to the sides, side walls of the burette. So you check whether there are droplets. If there are droplets in the sides of the burette, it means that the burette is not clean enough. So you repeat the procedure again. After establishing that the inside surface is clean, rinse the burette with distilled water. If the burette is to be used immediately, you can rinse it with several portions of the liquid which is to be measured, or which is to occupy the burette eventually. So you fill it with, so after rinsing it with small portions, then now finally fill it with this solution which you want to use. Now that is chemical cleanliness, or for analytical procedures, whereby after cleaning you also rinse with that solution which you are going to eventually use. That is chemical cleanliness. Now the same procedure should be used also to clean the pipettes. So that's the procedure which you have done for burette, can also use for cleaning the pipettes as well. Okay, so moving forward, so for cleaning highly contaminated labware, now when we speak of highly contaminated labware, this could be obstinate dirt which may not be removed by general cleaning methods. This can be done by suitable cleaning powder and a brush. So trisodium phosphate solution together with a little pumice powder should be efficient cleaning mixture. It may be necessary also to use a solvent such as acetone and a caustic solution to remove the adhering substances. After washing the glass, it must be thoroughly rinsed in clean water. The glass is then left in an inverted position to drain and dry. Small items such as test tubes may be dried in an oven at a temperature above 100 degrees, while large items of glass may be dried in a drying cupboard. So if the apparatus which has been washed is required immediately for use, you can flush it with a spirit, methylated spirit, followed by ether. So methyl spirit you can also use ethanol in place, 70% ethanol. It is then finally dried on the hot air oven. Now, glassware which is grossly contaminated may need special cleaning treatment after cleaning by the general methods. For oil and grease, this can be done by removing the oil by shaking with warm detergent solution. It may require one to use some scouring material. It could be some form of paper, sawdust, or that washing brush. So after scouring, it is then washed out with water. Okay. Then it can be finally washed with hydrochloric acid and then finally with distilled water. That is to make sure that all the grease has been removed from the glassware. So now there is this other type of grease known as the silicone grease. Now when cleaning, it is imperative to ensure that you use the cleaning solution or agent which is soluble with the dirt. So for grease, if you use water alone, water is not soluble in grease, so you may not achieve. So now for silicone grease, which is more difficult to remove, you first rinse the glass with paraffin or suitable hydrocarbon solvent, then clean with a warm solution of chromic acid. Alternatively, after the hydrocarbon has been used, the glassware may be cleaned with a warm solution of one of the following. Now you can use a solution prepared by 5 grams sodium perborate in 100 ml of 10% sodium hydroxide solution. So that is 1. You can also use 10 grams of sodium hydroxide and 5 grams of borax dissolved in 100 ml of water. Alternatively, you can also use 10 to 15 milliliters of 50% potassium hydroxide solution in 100 milliliters of industrial methylated spirit. Okay, another alternative 4, you can soak in fuming sulfuric acid, that should be Kong. You can also clean with carbon tetrachloride, and also you can use hot detergent such as T-Pol 10 parts, water 4 parts, paraffin 45 parts, all these heated and boil, heated to boil and use it while it is still hot. Okay, so for tar, we can use benzene or any other suitable solvent, followed by cleaning with an abrasive powder. For carbon, it is a bit difficult to remove, and soaking in caustic soda, which is like sodium hydroxide solution, is effective enough. You don't need much. Also, when carbon is very obstinate, heat small quantities of chromic acid in the vessel. Obstinate carbon can also be removed by using a steam heated acid cleaning bath. One can also use a mixture of 2 parts trisodium phosphate to 1 part sodium oleate in 16 parts of water. So all these are just alternatives of how to remove carbon stains. Can also heat a few grams of sodium sulfate in a flask, offer a Bunsen burner flame. So this method helps to loosen the carbon deposit. Once that is done, you can easily scour and use the normal methods of cleaning. As for stains, this can be done using a saturated solution of ferrous sulfate in dilute sulfuric acid. Permanent stain may be removed by sulfurous acid. Iron stains are removed by hydrochloric acid diluted with an equal amount of water. We also have other stronger ways. If the stain is much stronger, we can use aqua regia, which is ratio 1 to 3 of hydrochloric acid to nitric acid. But let's check this out first. So for harder deposits, which are much, so it is easy to remove the deposit if their nature is known. But if you don't know their nature, then it will be a bit difficult. So deposit of chalk, which can adhere to the walls of the glass vessels after boiling, can be removed by dilute hydrochloric acid. However, if the deposits adhere firmly to the walls of the vessels, a scouring agent together with a cleaning agent like a sand, glass beads, lead shots, etc. can be used. However, you should be careful with sand because it scratches the glassware, particularly the soda glass, which is much susceptible to scratches. Now, if the nature of the deposit is unknown, then it will not respond to the normal washing methods. So, chromic acid mixture can be used. A cold solution called universal reagent for cleaning glassware consists of 5% hydrochloric acid, 33% nitric acid, 2% TPOL, 60% water, and this will be effective for grease, carbon, and mercury contamination. So I said when you mix hydrochloric acid with nitric acid in ratio 1 to 3, so that is known as aqua regia. Aqua regia. Okay. So now prolonged treatment should be avoided. Prolonged treatment should be avoided. The reagent should not be used to clean volumetric flask as well. Now, for those glassware which are used for analytical work, using chromic acid or this aqua regia will dissolve glassware, and when it dissolves, it will interfere with its accuracy because the volume of the glass now will change. It will increase since the glassware will be, it will eat out parts of the glassware. Okay, so I think that should be that for the day. Okay, now there is also Dicon 75 cleaning concentrate, and this may be used in place of chromic acid. If you don't have chromic acid, you can use Dicon 75. You can just purchase that one. It is a non-foaming surface acting agents. We call those, they are also referred to as surfactants or surfactants, surface acting agents. It is non-corrosive and it is also non-toxic. So this is very ideal for general laboratory use, and it can be rinsed off the material being cleansed without leaving traces of the detergent. So if you remember, I said that any cleaning is effective or is good if you can be able to remove that cleaning agent completely from the labware. So you should ensure that even after cleaning, you remove that cleaning agent from the labware completely. Okay. So so when cleaning volumetric apparatus, which I said we must be careful with them, so volumetric glass should be cleaned and free from all greases. Hydrochloric mixtures and strong solutions should not be used, since I said they are used for analytical work. Now, for accurate work, cleaning with chromic, you can use chromic acid cleaning solution, but I said we must avoid prolonged use. Now, so you fill the apparatus with the cleaning solution and leave it to stand for 12 hours before rinsing and drying in the oven, hot air oven. Pipette should stand in a tall plastic measuring cylinder. You will allow it to stand in a tall plastic measuring cylinder. Then you soak for that 12 hours. Then now you can rinse. For volumetric glassware, they should not be heated or cleaned in hot water, since the glass takes a long time to contract to its original form, which can eventually lead to errors in the measurements. Okay, so you avoid using hot water, particularly when you want to use it immediately. Now, when cleaning and greasing stop cocks or the stoppers, so first of all, you clean them thoroughly, then rinse them in either to prevent them from binding or freezing, and then rinse them slightly by indirect heat. Then smear some grease down one side of the keys and reinsert the key in the barrier and rotate until the grease forms evenly. It forms an even film. So to prevent the keys from sticking when strong alkaline are used, the key should be cleaned and ground, and the ground surface rubbed with graphite pencil until completely blackened. The key is then greased in the normal way. Suitable lubricants for the stop keys are pure Vaseline. So to make a suitable lubricant, you take pure Vaseline. You can also take a mixture of Vaseline and resin cerate. Also, a mixture containing 1 part of beeswax to 3 parts of pure Vaseline is very good. Also, ideal greasing agent will consist of grease consisting of 1 part of soft rubber black added in small pieces to a mixture. Okay, so you heat this to 140, between 140 to 1500 degrees, and stir them continuously until thoroughly mixed. Okay, so that is the end of that. Okay.